Other than prime factorization, we're going to be working with what the textbook calls unequal quantities. But you can, although it says unequal quantities, really I want you to think of these as equations and not unequal, but equal quantities, because we're going to make them equal. Even though the reason they call them that is initially in the statement, they're going to be read as not equal. And you're going to look for some key words like, right here, is 42 less than? It's not is. Before it's always been, it just said is. You know, something is something else. But now it's not saying it is this, but 42 less than. So here's the way we're going to do this. I like to read through these. Twice a number is 42 less than negative 102, and then we're going to have to solve and find the number. But in setting up the initial equation, and it originally here is unequal, twice a number is 42 less than negative 102. It doesn't say twice a number is negative 102, but it's 42 less than. So oftentimes we'll leave a space here. Twice a number is 42 less than. So I'm going to leave a space and say twice a number is negative 102. But it's not. Twice a number, if we were to think of our equation as a balanced scale, twice a number is not negative 102. Twice a number is 42 less than negative 102. So really, if twice a number is 42 less than negative 102, the scale looks like this. This side's heavier because this side is 42 less than this side. So how would I make it balanced if I knew that twice the number is 42 less than negative 102? I'd have two ways I could balance this scale out, right? If this side is 42 more, I could make this equal by adding 42 to this side, right? If it's 42 less, if I add 42, won't it be equal? Sure it will. So this, if I add 42, would make my equation equal. It would no longer be tilted. But I have another choice. If this side, this is 42 less than this side, then if I subtract 42, that means this side's 42 more, right? If this is 42 less, the left side here is 42 less, that's why it's kind of up in the air. That means this side's 42 more. And so my other option is to add 42 to this side. Either way, I'm going to take this and I'm going to balance it out. Best trying. So, back to the original, I've got two choices here to make this equal. Twice the number is 42 less than. To make it equal, I could add 42 to this side, or I could subtract 42 from this side over here, and that would make it equal. So we'll add 42, even though, quite honestly, it's probably better off a little faster the other way, but I've already got it written in. We're going to end up subtracting 42, 2n equals negative 144, divide by 2, and equals negative 72. So, we got to get used to this idea that they're not originally equal, but we are going to make them equal. We're going to make them equations. Grab my screen here. Similar problem. 5 times a number is 72 greater than, I'm going to underline that, is 72 greater than the opposite of the number. So I leave space again. 5 times a number, skip this part, the opposite of the number. So if I think about my scale, 5 times a number is 72 greater than the opposite of the number. It's not equal. This is a lie. 5n does not equal negative n. 5 times the number is 72 greater than. So really, the scale is tipping this way, because 5 no idea why that's doing that. The scale is tipping this way because 5 times the number is 72 greater, it's heavier. So there are 2 ways to make it equal. I don't want it tipping this way. I want to make it equal. Right now this is heavier. If I subtract 72 from this side, they will be equal because it's 72 greater. The other possibility, though, that would work just as well, if this is 72 greater, then if I add 72 to this side, then they would be equal. So let's get the scale out of the way, which means I got to back up a little bit more. So let's say we're going to subtract 72 from this side since it's 72 greater. Now they're equal. We got to work to solve. Subtract 5n from both sides. Positive 5n, negative 5n cancel out. Negative 72 equals negative 6n. Divide by negative 6, divide by negative 6. These reduce to 1. 1 times n is n. N equals to a negative. A fraction is a division problem. Divide a negative by a negative. You cancel out to become a positive. N equals 12. We could plug this guy back in and we could find out if it's true. 5 times n would be 60. 60 minus, this is the original equation. And 60 minus 72 is negative 12. Negative 12 equals negative 12, so we did it right. One more. Similar to the other problem. Took them from the practice problems in the book. 5 times the number is 21 less than twice the opposite of the number. So I like to underline these to know that I'm going to skip it. 5 times a number is 21 less than, say is equal to, twice the opposite of the number, negative 2n, twice the opposite of the number. 2 times the negative n, I just switch the negative around with the 2. But this is not true. 5n does not equal negative 2n. 5n is 21 less than. So when we think about the scale, if it's 21 less than, it's higher up in the air. 21 less than. So if it's 21 less than, our choices to make it equal to then would be to add 21 to this side, and then it'd be equal. Or, if this originally was 21 less than, that makes this 21 more. So the other choice is to subtract 21 from this side. Both would be fine. Let's add 21 over here. And let's work to get n by itself. Minus 5n, minus 5n, 21 equals negative 7n. Divide by negative 7, divide by negative 7, n equals negative 3. You can plug that back into the original problem. We plug in negative 3 to this work. Negative 15 plus 2 equals sorry, this is 21. So I wrote this one work. Negative 2 times negative 3 is positive 6, and sure enough, if we added negative 15 and positive 21, that would be 6. 6 equals 6.